Okay, so I want to go through the Conics worksheet for you. I already have everything done, but I want to explain every step. Really remember, all you have to do is you have to make sure you know what kind of an object it is. Once you know what that is, you need to be able to complete the square on it. And then once you have it in that completed square form, you have to know what form you need to get it in so that you can find the appropriate things for the graph that you can make sure you graph it. So the first one we decided in class was an ellipse because they're both the same sign. They're both positives once you get them on the same side of the equal sign. And they're different. If they were the same, it would be a circle, but since they're different with the same sign, it's an ellipse. So what did I do? I grouped the x squared and the x term together. I factored out a 4. That's where this came into play, x squared minus 4x. Then I grouped the y squared and the y term together. I factored out the 9. So I got y squared plus 2y. Now I usually leave a blank because that's where I'm going to complete the square, but I actually rewrote it so you could see what I did. I took half of negative 4, which is 2. 2 squared is 4, so that's what I added here. But what did I really just add? I really added 16. Don't forget, if there's a coefficient out in front, you have to decide what did I really add. 4 times 4. So I added 16 over here. Here I took half of the y coefficient, which is 2, so half of 2 is 1. Squared is 1. What did I really add? Because there's a 9 out in front of there, I really added a 9. So I added that on this side. So whatever I do to this side, I have to make sure I do to this side. So this now is a perfect square, so I wrote it as x minus 2, whatever half of that is, squared. This became y plus 1 squared. I have to keep the 9 out in front of that. I have to keep the 4 out in front of that. Over here I added 11, 16, and 9 add up to 36. Alright, now if this were a circle, you might do something a little bit different, but this is an ellipse. So ellipse, we have to get that to be a 1. So we divided every term by 36. So we got x minus 2 squared over 9, because 4 divided by 36 reduces to 1/9. 9 divided by 36 reduces to 1/4. That's why there's a 4 in the denominator, and you still have your y plus 1 squared and equals 1. So I just divided every term by 36. So once you know that that's an ellipse and you get it into this form, you have to find all the parts. Center is at 2, negative 1. Be careful that this goes with the x and that goes with the y. So 2, negative 1. It's always opposite of what's inside that function. This tells me the stretch of the x's. So from the center 2, negative 1, I'm going to stretch the x's by 3. So I'm going to add 3 to my x value. That's where 5, negative 1 came in. I'm going to subtract 3 from my x value. That's where negative 1 comes in. So when I graph it, if that's my center, I went 3 units to the right and 3 units to the left. And then my y stretch is 2. Remember, this is the square of it, so square root of 4 is 2. So I need to know that from my center, I'm going to keep my x value, but I'm going to go 2 up and I'm going to go 2 down. So when I added 2 to the y, I got 1. When I subtracted 2 to the y, I got negative 3. So again, from my graph, I can see I went up 2 and I went down 2. So you either can list these vertices on your graph, or if you separately want to list the vertices, but I need to see those somewhere. I need to see what the center is. So don't just do it with tick marks. I need to either have you label it here, or it's easier if you just write it off to the side and then write what your 4 vertices are, because you have an x stretch. So you'll add the x stretch to the center, and you'll add the y stretch to the y of the center. Now, if those are numbers that don't come out nicely, if these aren't perfect squares, that's okay. Just take the square root of whatever it is, and again, if it's the x stretch, you add and subtract it from the x of the center. If it's the y stretch, you add and subtract it from the y value of the center. All right, let's talk about number 2. Number 2 is, we decided in class, because one's positive and one's negative, that it's a hyperbola. So I grouped the y's together, I grouped the x terms together, and I factored out the negative 4 while I did that. Don't forget that becomes a negative 2x. Then I completed the square. Half of this was negative 2, squared is 4. Half of negative 2 is negative 1, squared is 1. So what did I really add? Here I added 4, because there's nothing out in front of it. There's a 1. Here, when I distribute that, I really added a negative 4, so I had to add a negative 4. So this becomes a perfect square. Y minus 2, again, it's half of that, squared, minus 4 times x minus 1, because that's what half of that is, squared, equals 4. That's what this comes out to. Again, because it's a hyperbola, I want to get a 1 there, so I divided everything by 4. So this is what I got when I divided everything by 4. So the center, be careful of this. This goes with the x. So the center is at 1, 2. Make sure that you know that the x, even if it's, minus here, it doesn't matter. It's what's inside here. That is a 1 for the x and a 2 for the y. So then to find the vertices, those sometimes are a little bit harder for me to find. So I actually have to graph these. From the center, I know I'm going to make this rectangle. And so my y's are going to get stretched by 2. So I went up 2 and down 2. Don't forget again, this is squared. And then the square root of 1 is 1, so I'm still going to go 1 out to the right and 1 to the left. That makes the rectangle, if you can see it, so it's actually on the axis. It's 2 units up from the center, 2 units down. It's 1 unit right and 1 unit left. You draw in your diagonals, if you can see, those are a little light. You draw in the diagonals of that rectangle, that's going to be your asymptote lines. So then for the vertices, I always forget, is it going left and right, or is it opening up and down? So what I do is I plug in a point. I'd say, okay, if I plug in x is 1, let's say, because I should get 2 answers, 1, 0 and 1, 4, if it opens up and down. So if I put in x is 1, this whole term is going to go away. So then I'm just really left with y minus 2 squared over 4 has to equal 1. And if I solve that equation, I get y minus 2 squared equals 4. And I find out, yeah, it does work when y is 0 and when y is 4. That would give me the answer that I would need. So I do know that when x is 1, this function is defined, or I shouldn't say function, this equation is defined. So I know that 1, 4 is part of it, so now I know that opens up, and 1, 0. Now just to show you how it would, if I tried the ones that didn't work, if I tried 0, 2, if I thought it went left and right, if you put in x is 0, and I try to solve that, and y is 2, if you look what happens when you put in y is 2, this whole piece becomes 0. So now you're going to get 0 minus all of this squared equals 1. Well, if this squared is positive, you have a negative something equals 1, that can't happen. So you have to make sure this first term doesn't give you 0. If the first term gives you 0, that is not going to work. So I know that I can't put in y is 2, so I know that these two won't work, because if I put in y is 2, it doesn't work. Or you can just sit and try to memorize it. If it's y squared comes first, it's going to open up and down. If the x squared is positive, it's going to open left and right. All right, and then the last one is a parabola. So I'll do this one fairly quickly. These are already grouped together, so I factored out the 2. I took half of this, which is 1, so I added 1, which really meant I added a 2, so I had to add a 2 out here. So this became 2 times y minus 1 squared equals x, because those canceled out. So I rewrote it just so I could see x equals 2 times y minus 1 squared. I put plus 0. So I make sure that I'm not adding anything, so I want to make sure I put plus 0. Because then that tells me the x value is 0, because remember, what's in with the y affects the y. So the y value is going to be 1. It's going to move 1 up. But the x value didn't get moved left or right at all, because there was nothing added there. So my vertex is at 0, 1. So if you're not adding anything out here, you have to remember that's a 0. You have to remember that affects the y. So 0, 1. If this is a positive, it's going to open right, because the y is squared. If it was a negative, it would open left. And by negative, I mean this 2. That coefficient, if it's positive, it opens right. If it's negative, it opens left. And again, it's sideways like this when the y is squared and the x is not. All right, and then I'll make another video for the back page.